So we've got this star system we're looking at. Plaskett's binary. I don't know, I should look that up on Wikipedia. And it's got two stars going around it, and they measured the velocity of the stars probably by looking at the light and how the light is shifted. That's what astronomers do. And so you got these two stars that they're circling each other. They're of equal mass, or close enough to being equal that it's good enough. And they're circling a center of mass, and they're going in a circle, so they have to have the same mass. And we measured their speed, and we say the period is 14.5 days. From this, we can calculate the mass of the stars, just by knowing their velocities, knowing that their masses are constant, knowing the period, which we can do by looking at data from a telescope. We can find it. So let's do it. Well, first of all, let's take a look at just one of the stars right here. It has a mass of m, and it's moving in a circle, so there is a centripetal force acting on it. But that force is the gravity from this other star. So the force of gravity is equal to g mm. Now they're identical mass, so that's going to become m squared over, now I'm going to call this r. But how far away are they? 1, 2r. So that's 2r squared, which I'm going to write as 4r squared, like that. Does that make sense? This is the gravitational force pulling on this star due to this star. And that you have to know where that 4 comes from, because I'm calling this the radius of the orbit, but the distance is really the diameter of the orbit, and you square that, you get 4r. You with me? Okay. Now, this is also a centripetal force. So this is going to be m v squared over, well, same m, over r. Not 2r, r, the radius of the circle, which is just r. So look what happens. One of the masses cancel out. One of the r's cancel out. And so we can now solve for m. So let's do that. M is equal to, well, 4 r v squared over g. Is that right? Did I do that right? Okay. Now we have a problem. We don't know what r is. We know what v is, but we don't know what r is. So we have, we have an equation with two unknowns in it. We need another equation. But here's what we know. We know the velocity of this, and it's moving in a circle. So what do we know is true about that velocity? The velocity is equal to 2 pi r over the period. But we know what the period is. I went ahead and changed it to seconds ahead of time. So solve this for r. R is equal to the velocity times the period over 2 pi. Everybody agree with that? Did I do that right? R equals this times this divided by that. Yep. So now I'm going to plug that into here. I should have used capital R. Stay consistent with my variables. And so now I've got m is equal to 4 times r, but r is v over the period over 2 pi times, and then times v squared. And this is all over g. Now before I plug in numbers, I'm going to make this prettier. It got kind of messy. We got 4 times the period times the velocity cubed over 2 pi g. But we know everything here. Everything is given. So now it's just a matter of plugging in the numbers. 4. And you got to make sure that you're using units that are compatible. So the period has to be in seconds. So 1.24 times 10 to the 6 seconds. And then the velocity, which is 220 kilometers per second. But what do we need it in? We need it in meters per second. So that's just 220,000 meters per second. But you got to cube that. And then divide that by 2 and pi. And then g is 6.67 times 10 to the negative 11 Newton meter squared per kilogram squared. And what do we get when we do all that? Well, hold on a second. Do I have a 2 in the wrong place? Oh, the 2 and the 4 cancel. I should have done that. You get m equals, and I'm cheating. I'm looking in the solution guide because I don't want to take the time to type it into a calculator. 1.26 times 10 to the 32 kilograms. That's a pretty big, heavy star. The sun is on the order of magnitude, well, it's basically, I think, 2 times 10 to the 30 kilograms. So it's, well, according to this, 63 times bigger than the sun, more massive than the sun. So these are big stars. If they're going to do this, they have to have this mass. By the way, you can now solve for r, right? You could now, based on what's given, you could substitute the other way and solve for the radius of the orbit. So by using Newton's law of gravity, you make observations of stars, you can figure out a lot of stuff about them. And people always say, oh, how do astronomers know that they're that massive? Well, because they know their physics, astrophysics. Okay, so, yeah.
Why does V equal 2 pi r?
Whoops. Why does V equal what? Oh. Why does V equal 2 pi r over the period? Well, this is the speed, right? Speed is distance over time. The distance around a circle is 2 pi r. And the time it takes to go around once is called the period, which was known. All right, that's all.